Hi and welcome. I hope everyone is okay. We will study on the geometric distribution in this video. As you remember, we passed this topic. We passed this topic in the last week or before break time. But I want to finish this topic by making a video because I want to pass the new topic. It's called the normal distribution. So in this lesson, we will both revision and the finish this topic. Okay, let's get started. Consider a situation in which we are attempting to roll a 6 with an ordinary fair die. How likely are we to get our first 6 on the first roll, on the second roll, on the third roll, and so on? We can answer these questions using the constant probabilities of success and failure. We can say that the probability of success, is P. So the probability of failure is have to be 1 minus P. Cause shortly, and I can say 1 minus P, it's Q. If I write P is the probability of success. If I write Q is the probability of failure, which is also 1 minus P. And then if you want to get 6 in the first roll, we can say the probability is P. If you want to get first 6 on the second roll, you have to get the first roll failure and the second roll success. So the probability of the failure Q and then the probability of success P. If you want to first 6 on the third roll, you have to in the first roll failure, in the second roll failure, and the third roll success. In the probability of first roll Q and the probability of second roll Q and the probability of third roll P, because we want to get 6 in the third roll. So it has to be the first roll failure, the second roll failure, and the third roll success. And if you look at this table, if you want to the number of first trial, the number of the one trial, and if you want to get a success, the probability is P. But if you want to get success in the second trial, the first has to be failure, the second has to be success. If you want to get third trial, you want to get success, the first one failure, the second one failure, and the third one success. If you want to get the fourth trial, you want to get success, the first one failure, the second one failure, the third one's failure, and the fourth one has to be a success. If you want to get nth or rth trial, so the first one failure, the second one failure, the third one failure, and so on. The n minus one failure, the nth one success. We have n minus 1 amount Q, and we can say Q to the power of n minus 1 multiply P. Please notice that how can you aware of how can you aware of you want to solve a question regards to geometric distribution. Firstly, you have to notice that the repeated trials are independent. For example, the first one and the second one don't impact for each other. The repeated trials can be infinite in number, and there are just two possible outcomes: failure or success. And the probability of success in each trial P is constant every time 1 over 2, or every time like has to be 0.5, 0.3, like that. And we can say that a random variable x that has a geometric distribution is denoted by x, and our variable name, x, is geometric distribution, and according to this notation, P is the probability of success, and the probability that the first success occurs under rth trial, we have to get the first r minus 1 times failure, q, and the first r minus 1 times failure, and then the rth trial has to be success, and then we can say q to the power of or r minus 1 multiply p. And the binomial and geometric distribution arise in very similar situation. The significant difference is that the number of trials in a binomial distribution is fixed from the start, and the number of successes are counted. For example, in the binomial distribution, we want to get 5 times success, or 2 times success, or 3 times success, and it doesn't matter these order, these like arrange. Maybe the first trial has to be success, and the third trial has to be success, and the 10th trial has to be success. So it doesn't matter the order, or the terms you think like that. And but in the geometric distribution, we have to get 1 time success, and it matters which time success. Maybe the first time success, maybe the second time trial has to be success, maybe the 10th trial has to be success. So we can say it is geometric distribution. Trials are repeated as many times as necessary until the first success occurs. And if you look at the notation in the binomial distribution, x, the variable of x, in the binomial distribution, the first term is n, the second term is the probability of success, and you can say in the binomial distribution you can get obtain r successes. The combination and the number of n trials, we can get r times success. It is combination, as you remember, and then multiply the probability of success r and the probability of failure m minus r. And if you look at the geometric distribution, the variable of x geometric distribution, like this p, the p is the probability of success. There is only one way to obtain the first success on the rth trial, and that is when there are r minus 1 failures followed by success. So the first trial failure, the second trial failure, the third trial has to be a failure, and then the r minus 1 trial is a failure, and then the rth trial success. We can say q to the power of r minus 1 multiply p. Okay, and if we study on a worked example, you can understand easily, I hope. Repeated independent trials are carried out in which the probability of success in each trial is 0.66. Correct to three significant figures, find the probability that the first success occurs. If you see these sentences in a question, you have to think this question regards to the geometric distribution, because the question tells us the first success occurs. The first success occurs, which is it has to be the geometric distribution. On the third trial, the probability of on the third trial. Firstly, we have to determine what is the probability of success, what is the probability of failure. The probability of failure, as you know, that 1 minus p. The probability of success 0.66. The probability of failure 1 minus 0.66, and we can say 0.34. And then we are looking for the probability of the third trial. So the first trial has to be failure, the second trial has to be failure, and the third trial has to be a success. So we can say q square multiply p, and we can say 0.34 square multiply p. Multiply 0.66, and I want to look at the result for using the short time. It is 0.0763, and the part of B on or before the second trial, on and or before second trial, which is we can get success the first in the first trial. We can get success or plus we can get success the second trial. So if we want to get success the first trial, which is P, and then if you want to get the second get success in the second trial, the first trial has to be failure, the second trial has to be success, and we can say 0.66 plus 0.34 multiply 0.66, and then I want to write the result. The result is 0.884. And the part of C, after the third trial. After the third trial, we want to get success after the third trial. So the probability of x greater than 3, and maybe we can get success in the fourth trial, or in the fifth trial, or in the sixth trial, or so on. And this situation goes on the infinite. So please remember that the probability or the value of probability, the sum of all probability values has to be 1. So we can say the probability of get success the first trial, the probability of getting success the second trial, the probability of getting success the third trial, and the probability of getting success the fourth trial, and then has to be equals 1. And we are looking for this part, and we can figure out this part, and 1 minus this part we can receive which we are looking for the probability, or and it's we can say this is the probability of x greater than 3. And we can say the probability of first p and the probability of the second trial we can get success q multiply p, and we can say q multiply p, and 0.66, 0.36 multiply 0.66, and 0.34 square multiply 0.66, and we are looking for the probability of x greater than 3. And then 1 minus this part, we will receive what we are looking for it. And then I want to write the result. It is 0.0393. Okay, and we can get we can talk about something in the geometric distribution differently. For larger values of r, the following results will be useful. Please think on that. If VR or if we roll a dice 5 times, which we might come across the situation, okay. For example, maybe we can, and we want to get 6, for example. Our success let be 6, for example. So maybe we can get in the first trial get success, or in the second trial success, or in the third trial success, or in the fourth trial success, or in the fifth trial success, or we can't get success. Maybe all outcomes of rolling the dice we can't get 6, for example. It means 5 times failure. Excuse me, 5 times failure is q to the power of 5. Okay, this is the sum of all probabilities values. As you remember, the sum of all probabilities values has to be 1. So if you want to excuse me, if you want to figure out this part, and also we can say this part, we can get 6, less or equals than 4 plus q to the power of 5, and it means 1. And then the probability of x get success for or less than 4, it means 1 minus q to the power of 5. So we can figure out the probability of x less or equals than 4 shortly 1 minus q to the power of 5. Okay, and we can access the result. For example, in the geometric distribution, if you are looking for the probability of x less or equals than r, you can get this probability 1 minus q to the power of r. Okay, for example, if you want to get success 10 or less than 10 trial. For example, if you want to get success in the first trial, or in the second trial, or in the third trial, or in the fourth trial, and so on in the 10th trial. To figure out this probability is very hard, is very long. So you can say that shortly it is equals to 1 minus q to the power of 10. Okay, and I want you to think on another thing. For example, if you want to find the probability of x greater than 4, x greater than 4, the probability of x greater than 4 means maybe you can get success in the fifth trial. Maybe you can get success in the 6th trial. Maybe you can get success in the 7th trial, and then so on, and this situation goes on to the infinite. So it means we can say another expression. This is 4 times failure. 4 times failure. So for example, we have some trial, and we have to do this trial goes on to the infinite, and we want to get success the 5th trial, or more than 5th trial. It means we have to come across in the 4th trial, failure. So it is the first trial failure, the second trial's failure, the third trial failure, and the fourth trial failure, and it is q to the power of 4. Okay, for example, if you want to get success greater than or equals than 10, so it is it is the probability of x greater than 9. And if we want to get success in the 10th trial, 11th trial, 12th trial, like that. So it is, we have to come across to failure in the 9 times. So in the 9 trials, we have to come across failure, and you can say that q to the power of 9. Okay, and because we want to get success in the first time in the 10th trial, maybe more than can be more than 10th. So we can say that the probability of x greater than r means q to the power of r, q to the power of r. And now we learned two things. The firstly, if we are looking for in the also geometric distribution, if we are looking for the probability of x less or equals than r, means 1 minus q to the power of r. If we are looking for the probability of x greater than r, is q to the power of r. Please notice that, and please aware of this situation, which situation I can come across if I sum or add to these equations. Please notice that if I sum to these both equations, it is the probability of x less or equals than r plus the probability of x greater than r and negative q to the power of r, positive q to the power of r cancelled 1. And please think on that. What is the mean of the probability of x greater less or equals than r? It is, the first time, the first trial success, the second trial success, and the rth trial success. What is the mean of the probability of x greater than r? The probability of r plus 1th trial success, the probability of r plus 2 get success, and infinite. And as you remember, all probabilities values, the sum of all probabilities values has to be 1. Okay, so in worked example, I hope you can understand easily. In a particular country, 18% of adults wear contact lenses. Adults are randomly selected and interviewed one at a time. Find the probability that the first adult who wears contact lenses is one of the first 15th interviewed. We can come across the wear contact lens in the interviewed. The ratio is 18%. So the probability of success is 0.18. The probability of failure is 1 minus p, so 1 minus 0.18, so it is 0.72, and the probability of failure is 0.72. One of the first fifth interviewed. So it is, we can come across to adults wear contact lens, which is maybe the 15th interviewed, maybe the 14th interviewed, maybe the first interviewed. It means like this. So we can say 1 minus the probability of failure to the power of 15. So if I subtract from 1, 15 times we can't come across the adults wear contact lens, which is in the 15th interviewed, I can come across the adults who wear contact lens. So we can say 1 minus 0.72 to the power of 15, and I want to look the example, but it doesn't matter which the result. It's so very important that our operations. And B, not one of the first 9 interviewed. Not one of the first 9 interviewed, which is maybe we can come across the 10th interviewed. We can come across the adults wear contact lens 11th interviewed. So it is the probability of X greater than 9 and greater than 9, which is we have to come across the 9 in the 9 trials every time failure. So it is q to the power of 9. Q to the power of 9, it is 0.72 to the power of 9. Okay, and we can pass the new example, and maybe I can find the result. The first question of result, the result of the first question, 0.949, and then the second result of the second part, which is 0.168. By the way, I have a little mistake. 1 minus 0.18, which is 0.82, 0.82, and 0.82. I want to make correction. Okay, and the other question. The sides of a fair 5-sided spinner are marked 1, 1, 2, 3, and 4. It is spun until the first score of 1 is obtained. So our success is to obtain 1. So the probability of success is we have 2, 1, and we have the number of all outcomes 5. The probability of success 2 over 5, and it means 0.4. And the probability of failure is 1 minus p is 0.6. And find the probability that it is spun exactly twice. So the second time we have to get success. The second time we have to come across success, which is the first time failure, and the second time has to be success, and 0.6 multiplied 0.4, and which is 0.24. And the most 5 times. At the most 5 times we have to come across to success. So it is the probability of X less or equals than 5, and it is 1 minus we have to come across the probability of we have to come across 5 times failure. So q to the power of 5. So it is 1 minus 0.6 to the power of 5. Okay, and C, at least 8 times. At least 8 times means X greater or equals than 8. And we can say the probability of X greater than 7. X greater than 7 means we have to come across to the failure in the first 7 times in the first 7 trials. So it is q to the power of 7 and it is 0.6 to the power of 7. Okay, and I want to finish this video here, and I will make a very short video after that, mode of the geometric distribution and expectation of the geometric distribution. I hope the video would be useful for you, and see you after time.